Hello there, great folks. Welcome to the first lesson of functions. Right. So today we'll be looking at what is a function. Right. So one might ask now, how is this even important? Because we're supposed to be seeing graphs here. So hold on. I truly believe that it is much important to learn about where something comes from if you want to really understand it. Right. So today I just have a simple Google definition here in terms of what a function is. So a function is described as the relationship between a set of inputs having one output. Right. So now that simply means that we are not expecting inputs to have more than one output. Right. So what are those inputs and output we are referring to when we talk about functions? Right. So now that are the x values and the y values. Right. So the criteria is each x value must have one output. So it means that we cannot have one x value having more than two y values. Right. So it means that a certain x value must have only one output. Right. Okay. So now let us check that. Let us get into the categories of functions. Firstly, we have a one-to-one function. Now, what is a one-to-one function? Now, that simply means that for every x value, right, there is a corresponding y value. Right. So I think this one it's self-explanatory. Right. 1 to 1. So one x value, one y value. Right. Okay. So this one is explanatory. Please do not confuse one x value, one y value with an x value having only one output. Right. You're still going to understand that as I'm going on with the different categories of functions. Right. So we're still dealing with one-to-one functions. Right. So what else do we have under this category? We have what we call many to one function. Right. So now what is a many to one function? Right. So a many to one function, it also still qualifies as this one, but it has a cherry on top of it. Right. So now the only difference there is that you can have maybe two inputs or two different inputs having the same output. Right. Now remember I said do not be confused with the set of inputs having one output. Now this means that a set of input must have its own, or it must have at least one output. It means that if I can have x being equals to 2 and have x being equals to 3, it's fine. They might share the same value, maybe being 4 and this one being 4. But what is important here is that these different x values must have only one output. Right. So this means that you cannot have one x value maybe being 3, one x value being equals to 3, but you can find that this has different outputs of 6 and 5. So this is not allowed. That is what I'm trying to explain here by saying that it should have a one output each. Right. So do not confuse the same and one output. Right. So I hope that you're not confused there. So please, let's go on to check the next category of the types of functions. Right. So the next one is a one to many function. So this one here, it's actually not considered a function. Why? Because it's actually goes against the rules or the definition of what a function is. Meaning it's this thing here where we'll find ourselves that a single x value For example, if we can have negative 2, 4, 3, then you'd find that, okay, this one would give us maybe an output of 16, but now you find that this 4 here will have different y values. Now you find that this one is 1 and this one is 6. Then this one here, okay, it's a good one, right? So this situation here, it's not allowed. So one input must have at least one output, right? Okay, so it must not find itself like the X here having different outputs, right? So please make sure you grasp this content, right? Do not be confused. If this does not make sense, please make sure you go back and play the video again and try to listen carefully and follow on as to what am I trying to explain here, right? So a one-to-many function, we don't have a one-to-many function. So that is why we're saying this is not considered a function, right? Right. So, okay, now let us move now to the next phase. Now we are going on to check on the vertical and horizontal test, right? So now one might also ask himself again, now how is it important to know the vertical and the horizontal line test, right? So let us quickly check it there, right? So what is the vertical line test? Right, vertical line test. So a vertical line test, we use it to test, we test whether a graph is a function or not, right? So you might find that, okay, we have, maybe let me throw up the Cartesian plane here. So we have a Cartesian plane, then we have a straight line function here, right? Let me call it f, right? So now how does this vertical line test? Now when we talk about a vertical line, we talk about something that is like this. Now this is vertical, right? So now you take your pen, you move from left to right, and you want to see how many times does this line pass my function here, right? So you can see that when we move from left, this touches this only once at this point, right? You'd see again that when we move to the right, it also touches once, right? So what does that mean? If it touches once, so if it touches once, then we can say, therefore, this is a function. Right. But what if it touches twice? For example, if we can have a situation like this, right? So we have our Cartesian plane, this is the x and this is the y-axis. Sorry for not doing that there, right? Then now we have something like this here. Now, when we do the vertical line test, right? So we take our pen again, we go on to the graph, we start from the left to the right. Now we are drawing with the vertical line test and see. Now, how many times does this line pass this graph here? So you'd see that it will pass at this point, at this point there. So now that is passing twice, right? Now let us move to the right. We check again, the right, it's also passing how many times? Twice at this point here. So it means that if it touches twice, therefore it is not a function, right? I hope that this makes sense and I'm not confusing you guys, right? So for you to understand this better, as I'm busy explaining it to you, it will be key to also kind of write this thing down and see what exactly am I talking about. Right. Okay. So now let us move from the vertical line test. Now let us go to the next important thing, which is now the horizontal line test. So now let me remove this here. Right. So what is the horizontal line test used for? Right. So the horizontal line test, let me throw that. Horizontal line test. Now, this is used to check if a graph is a one-to-one or a many-to-one. Remember, we don't have a one-to-many, and a one-to-many is not a function. So we are only checking at these two here, a one-to-one and a many-to-one function, right? Okay, now let us check at how this horizontal line test works. Now let us say we have the Cartesian plane again and a graph, right? So this is your x-axis, this is your y-axis there. Now we have a graph there, right? So this is a straight line graph, right? Okay, so now you take your ruler again. We want to perform this horizontal line testing and see, now, is this a one-to-one or a many-to-one function? Now, something that is horizontal is something that has to be like this, right? It's no longer like this, but now it's horizontal like that, right? So you go again from left to right. Now, let us check from left here. If we draw a horizontal line, we'd see that this passes only once. Where? At this point. Do you see that? Don't say now it cuts twice because now you are looking at this axis here. No, we're looking at the function. Let's say this is f, right? So you go again to the right. Let's check. How many times does this horizontal line pass? Let's check here again. How many times does it pass the function? Once. So if it passes once, therefore, it is a one-to-one function. Right. I hope that, guys, you still with me and this thing is making sense to you. So as I said, for you to follow, please make sure that you're doing the same thing that I'm doing down there on your book. Right. Okay. Now let us check again. How can we see if a graph is a many-to-one? Right. So you'd find, okay, that, okay, now we have a function here. Right. Now there is an x, there is a y, right? Okay. Now that you'd find, okay, we have this type of a function here. Now this seems familiar, and this type of a graph is called what? A parabola, right? But that's not what we want to talk about today, right? So we want to prove this thing of one-to-one and many-to-one. Now, we take our pen or our pencil again, we go to the function. We put a horizontal, or we put our ruler horizontally. Now we want to check from top to bottom, right? Okay. How many times does the horizontal line pass this function? Right. So, sorry about that there. The inconsistency. Right. Okay. Sorry about that, but I just hope the concept that I'm trying to teach does go through. Right. So, okay. So you can see that now the horizontal line passes this graph twice, at this point and at this point. Right. Okay. Now let us check down here again. How many times does this line pass this function? Twice. Wait, at this point and at this point. Now we can make a conclusion to say, okay, if it passes more than once or twice, so if it's twice or more, therefore, what are we saying about this? It is a many-to-one function. Right. So this is what the horizontal line test and the vertical line test is all about, right? So I hope that this, guys, made sense to you and that you will learn a lot from this video. So please, guys, and please make sure that you follow us on all our social media platforms at MM Tutorials. Then please make sure you also subscribe to our YouTube channel at also MM Tutorials. Right. So make sure you share with others so they also get this information, right, that you're getting. Thank you, guys. This is the end of our first lesson. So make sure you join us on the second lesson, where we'll now be looking at the inverse functions of a straight line graph. Right. Thank you very much.